Good morning, with you your math teacher Mrs. Rabab Ahmed for covering lesson 3 in unit 1, Algebra prep 3, which is polynomial function. Now let's move to the slide number 2. The meaning of the function. Our lesson is a polynomial function, so we need to study the meaning of the function and the meaning of the polynomial. At the beginning, we are talking about the meaning of the function. Let x and y are two non-empty sets. Any relation R from x to y is said to be a function if for every element in x is one and one only image in y. So f is a function from x to y. We have two sets, x and y. The first set is called domain, and the second set is called codomain. Also, we have another definition, which is the range. What is the range? The range is the set of images of all elements of the domain by the function f. Range means the images of the set. So we can say the range is subset from the codomain. Now we are moving to slide number 3 to talk about the polynomial. What is the polynomial? Polynomial is the sum or difference of a collection of algebraic terms. If we have one term, it's called a monomial. If we have two terms, sum or difference, it's called binomial. If we have three terms, it's called trinomial. For example, 3c plus 7, it's a polynomial. 7x to the power 2 minus 5x plus 3, it's a polynomial. And the last one, 2x to the power 4, y to the power 3 plus 3xy to the power 2. Now we are moving to slide number 4. The conditions of being a polynomial. What is the condition to say this is a polynomial function? We have two conditions. The first one, each of the domain and the codomain of the function is the set of real numbers. The second one, the power or the index of the variable x, it must be a natural number. For example, the function f of 1 x equals 3, it's a constant function or a function, it's a polynomial. The function 2, f of x equals 2x plus 5, f of x equal x to the power 2 minus 2x plus 1. All the previous polynomial function are polynomial. But look to the function n of x equal x to the power 3 plus root x minus 3 is not a polynomial function because its a domain is not R, not belonging to R, because we can't find the image of the real negative number. That because the square root prevents me from using a negative number. We can't say square root to the negative 3, for example. The function kx equal x to the power 2 minus 1 over x is not a polynomial function. That because the index of the x is negative 1, not belonging to the real number, natural number. Try to remember we haven't any number or any fraction can represented by 1 over 0, that meaningless. Let's move to the slide number 5. Please note to me, we should know if the function is a polynomial function or not before writing the rule in the simplest form. For example, the function tx equal x, open the bracket, x plus 3 over x is not a polynomial function. Why is not a polynomial function? That because it's a domain not belonging to R, because we can't find the image of the number 0. Try to substitute 0 in x. We have 3 over x, that means we have 3 over 0. And we studied before 3 over 0 or any number over 0 is meaningless. But if we put the function in the simplest form, it will be x to the power 2 plus 3. This is the rule for another polynomial function. Let's move to the slide number 6. How can we determine the degree of the polynomial function? At the beginning, we want to know what is the degree of the polynomial function. It is the highest power of the variable in the function rule. For example, f of x, let's try with the first one, f1 of x equals 3x minus half. Is the degree, its degree is the first degree, that because the highest power we have is 1, x with power 1. The second one, the function f2x equals square root 5 x to the power 2 minus 3x plus 4. This polynomial for the second degree. Pay attention, square root 5, the square root on the number, not on the variable x. Okay? Number 3, the function f3x equal x to the power 3 minus 5x to the power 2 plus 4. Its degree is the third degree. Its degree is the third degree. We have a note. When we want to determine the degree of the function, we should simplify the rule of the function before telling its degree. Okay? Let's move to the slide number 7. We have here an example. If f from R to R, mention the degree of each of the following one. F of x equal, as we see, x bracket x to the power 3 plus x to the power 2 minus x to the power 2 bracket x power 2 minus 2x. At the beginning, we must simplify the function. Okay? So, after simplifying, we must determine the degree. Okay? It will be the third degree, that because the polynomial function, at the end, it will be 3x to the power 3. Number 2, f of x equal x to the power 2 plus 2 plus x all the bracket to the power 2. At the beginning, we must simplify the bracket. The first by itself, the second by itself, first by second by 2. After simplifying, we have 4x to the power 2 plus 4x to the power 3 plus x to the power 4. So the function with the fourth degree, that because the greatest power here is 4. Let's move to the slide number 8. We have here another example. If f is a polynomial function where f of x equal x to the power 2 minus 2x plus 5. Number 1, find f of 1, f of 0, f of negative 2, f of half, and f of root 5. Number 2, prove that f of 2 root 2 plus 1 equal to f of 1 minus root 2. The solution. Number 1. If I asked you to find f of 1, that means you will replacement every x with 1, or substitute every x by 1 to have 1 to the power 2 minus 2 times 1 plus 5. As we see, we cancelled every x and put 1 to get 4. And by the same way, we will get f of 0, f of negative 2, f of half, and f of root 5. Number 2, I want to prove that f of something equal f of something. That means I will replacement x with 2 root 2 plus 1 to get the value of it is 6. Then we will find f of 1 minus root 2 to get the value, then multiply it by 2 to get also 6. So the two sides are equal. That's all, and thank you.